right, so today we're discussing partial fractions. So very small topic. Hopefully we'll be done with it by tomorrow maximum. It's usually asked with the topic binomial expansion, which we'll study next, and also integration, which we'll be studying in a few weeks. So there are a couple of cases we need to discuss. Case one is when the denominator is linear. Denominator has linear, non-repeated factor. For example, factors should be the right word. So in the denominator, we have x plus 5 times x plus 3. And in the numerator, we have 2x plus 8. Okay. Now, what we have to do is break this down into partial fractions. What does it mean breaking something down in partial fractions? Let's just talk about that for a bit before we come back to this case. So from O levels, you know that if you have a question like this, x upon 3x plus 2 plus, let's say, 2 upon 1 plus x. You're asked to simplify this or rewrite this as a single fraction. Then you know what to do. What would you do in O levels? You would take LCM in the denominator, 2x plus 2, 1 plus x. And the numerator would be x plus x squared plus 6x plus 4. Simplify that, we would get x squared plus 6x plus 7x plus 4 upon 3x plus 2 over n plus x. So in O levels, this used to be the question and this used to be the answer. It's not a great example to start with, but I hope you get the general idea. That was the question, this was the answer. Now what will happen in this case is that this would be the question now. And you'll have to, in a way, retrace your steps. And this would be your answer. All right. So now you go from here to here. And there are a couple of cases that you need to take care of to get the right answer. So back to the case one, where the denominator has a linear non-repeated roots. We'll talk about non-repeated in a while as well. For now, just consider linear roots. So x plus 5 is a linear value and x plus 3 is a linear value. Sorry, I said root, I meant factors. Okay. So what happens when in the denominator you have two non-repeated linear factors? Now you have to change it in this form. There will be something in the numerator, x plus 5, and plus there'll be something in the numerator of the second fraction, x plus 3. I'm calling this A, I'm calling this B. Okay. Whenever there are linear factors in the denominator, you write A here, B here. If there was a third linear factor, for example, x minus 2, you would have added another fraction here, C upon x minus 2. So there's just a single letter at the top when it's case one, non-repeated linear factors in the denominator. Okay. Now, how do we solve this? We take LCM at the right-hand side. So we have x plus 5, x plus 3, Numerator becomes a times x plus 3 plus b times x plus 5. Left hand side is the same, 2x plus 8 and x plus 5, x plus 3. Now we can cancel this with this and we're just left with 2x plus 8 is equals to a times x plus 3 plus b times x plus 5. Now I need to find the value of a and value of b using substitution. So if I say let x equals minus 3, that would be very convenient because if we change this into 0, and then a term will get eliminated and we'll be able to find the value of b. So we're going to substitute x equals minus 3. So what do we get here? We get 2 into minus 3, which is minus 6 plus 8, which is 2. So we have 2 equals a times 0 is 0. A gets cancelled. Plus b times x plus 5 would be minus 3 plus 5, which is 2 again. So we're getting 2 is equals to 2b. That means b equals 1. So we got the value of b. Now we need another substitution to find the value of a. What is that going to be? We're going to make this 0. So we're going to say let x equal minus 5 so that the b term now becomes 0. So we have 2 times minus 5 plus 8 equals a times minus 5 plus 3. So we have minus 10 plus 8, which is 2. And times minus 2 is equals to minus 2a. So a is coming out to be minus 1. So we get, in fact, a should have been 1. क्या गलत हो रहा है इधर? I might have copied the question wrong.
मैम ये -10 + 8 -2 हो जाएगा, आपने 2 लिखा है.
Oh yeah, this is mine. Okay, thank you. And then a is 1. So now we have our answer. Just replace a and b with 1. So 1 over x plus 5 plus 1 over x plus 3. If you have time to recheck your answer, now solve it like you used to in grade 8. Take LCM, simplify, and you should get this back. Okay, this is case 1, where you have linear factors in the denominator, but none of the factor is being repeated. So in that case, you use A, B, and C at the top of the respective factors. Okay, that was case 1. Now let's do case 2, which is the repeated linear factor. In denominator. Okay, so what happens now is, I should have done another example for the previous case, but chalo nahi. Okay, so here's another case. You have a linear factor x minus 1, which is not repeated. It's the power is 1, but then you have another linear factor, but it's repeated because it's being multiplied twice because there's a power 2 on it. And the numerator here is 6x squared plus 11x minus 8 equals. Now again, you're going to split this into 3 fractions. Plus sign. First one is, first denominator is x minus 1. Second denominator is x plus 2 without any power, or the power is 1. And the third one is x plus 2 power square. So now the alphabet here is going to be A, the alphabet here is going to be B, and the alphabet here is going to be C. Right? So the repeated denominator is written twice, once with power 1, and then again with power 2. Okay, so that's the second case. So now we're going to take LCM at the right hand side. It's going to be x minus 1 times x plus 2 whole square. So this one, the numerator and denominator gets multiplied with x plus 2 whole square. X plus 2 whole square. Here it gets multiplied with x minus 1 and x plus 2. In the denominator as well, x minus 1, x plus 2. And the last one just gets multiplied with x minus 1. Okay, so we have a times x plus 2 whole square plus b times x minus 1 and x plus 2 plus c times x minus 1. The left hand side remains the same. Okay. And then this and this gets cancelled, and we have 6x squared plus 11x minus 8 equals a times x plus 2 whole square plus b times x minus 1, x plus 2 plus c times x minus 1. Okay. So what I'm going to do first is let x equals, if I want to eliminate this, I'm going to take let x equals to minus 2. And it will not only eliminate this, but it will also make this 0. That would eliminate b as well. So we'll be able to find the value of c. Okay. So we get 6 times minus 2 whole square plus 11 times minus 2 minus 8 equals a times minus 2 plus, in fact, let's just write 0 there. So we have 0 plus another 0 plus c times minus 2 minus. So we're getting minus 3c at the right hand side. And we have 6 times 4 minus 22 minus 8, which is minus 6. So we're getting c equals to 2. Let me confirm it. That is correct. Okay. Now we have the value of c. Now I'm going to substitute 1 instead of x, in place of x. So let x equals 1. What happens now? This will become 0. This will also become 0, and we'll be able to find the value of a. So we have 6 times 1 square plus 11 times 1 minus 8 equals a times 1 plus 2 is 3, 3 square. So we have 9 here, and we have 6 plus 11 minus 8, which is 9. We have 9, a equals 9. So a equals 1. And that is correct. Oh. Now we need the value of b. To find b, we can't use x equals to 1 because then b gets eliminated. Similarly, you can't use x equals to minus 2 because for that, b also gets eliminated. So we have to use some other value of x and make it as simple as possible. So I'm going to take x equals to 0. And also I already have values of a and c, so I should be able to find b from here. Let x is equals to 0. So when x equals to 0, 6 times 0 square is 0. plus 11 times 0 is 0, and then minus 8 equals, A came out to be 1. So it's 1 times 0 plus 2 whole square, which is 4, plus B times A is 0, so we have minus 1 times 2, and then we have plus C times minus 1. So we're getting minus 8. In fact, C was 2, so 2 times minus. Okay, so we're getting minus 8 equals 4 minus 2B minus 2. So we're getting 2 here, and then minus 10 is equals to minus 2B, which is giving me B equals 5, which is correct. So finally, you break that into partial fraction, and by using the values of A, B, and C that you got. So we get A is 1 upon x minus 1 plus 5 over x plus 2 plus 2 over x plus 2 whole square. Yes, that is the correct answer. Oh, let's do case 3. In fact, let's do another example for case 2. Okay. So now we have 6 upon x cubed minus 4x squared plus 4x. So we don't see any factors in the denominator. Instead, we see a cubic expression, but the cubic expression can be factorized first. So let's do that. We can take x common, and we get x squared minus 4x plus 4. Numerator is still 6. And this can be written as x. Let's do middle term breaking of this, x squared minus 2x minus 2x plus 4. So x is common, x minus 2 minus 2 is common, x minus 2. So we have x minus 2 and x minus 2. In other case, repeated linear factor. So it becomes 6 upon x times x minus 2 whole square, which means, just give me a second. Okay. So we have 6 upon x, then x minus 2 whole square. So we have linear factors in the denominator. One factor is x, which is not being repeated, and the other factor is x minus 2, which is being repeated. So then the rule is we write x plus x minus 2 with power 1, and then x minus 2 with power 2. So that would be A, this would be B, and C. Take LCM. Left-hand side remains the same. The denominator is x times x minus 2 whole square. So here we have to multiply x minus 2 whole square in the numerator plus denominator. And here we have to multiply x minus 2 once and then x minus 2 once and then x. And here we have to multiply an x and an x. Okay, so we have A times x minus 2 whole square plus B times x minus 2 plus Cx. Okay. So again, the denominators get cancelled. So I'm going to directly start substitution, and I'm going to start with let x equals 2. So we get 6 equals, the A term gets cancelled because it gets multiplied with 0. Similarly, the b expression gets cancelled because it's being multiplied with 0, and then we get is equals to cx, which is 2c, so that gives us c equals 3. Next, I'm going to substitute x equals 0, because that would eliminate this and this, both of them. Oh, just give me a couple of seconds. So x is 0 now. So 6 is still 6. We have a times minus 2 whole square, which is 4. So I'm writing 4a plus b terms become 0 and c is also being multiplied with 0. So we have a equals 3 by 2. Yes, that is correct. And now again, to find the value of b, you need to take a different value other than x is equals to 0 and x equals to 2, because for both of them, b becomes 0. So I need a simple value of x that I can substitute. I'm going to take let x equals 1. So that gives us 6 equals a is 3 upon 2. Then 1 minus 2 is going to be minus 1, whole square of that is still 1. Plus b is what we're trying to find, times x, which is 1. And then 1 minus 2, which is minus. And then plus cx, so that's just c. And also we already have value of c, so that's 3. So we have 6 equals 3 upon 2 minus b plus 3, sending b to the left hand side. So we have 3 by 2 plus 3 minus 6. 3 by 2 plus 3 minus 6 is minus 3 upon 2. So we have the values of a, b, and c. So now we can write the partial fractions. So again, we're writing this, the correct values of a, b, and c. So a was 3 upon 2. So we get 3 upon 2. And then there's an x in the denominator. 3 upon 2x. b is minus 3 upon 2. So minus 3 upon x minus 2. And plus, you need to ignore this red part. I did this working to take LCM and simplify. Now we're ignoring this. So plus c over x minus 2 whole square. So the c is 3. So this is the answer in partial fraction.
तो वैसे 3 over minus 2 over 2
There's a 2 missing, yes. Yeah, 3 over 2. I think rest is correct, yes. Okay, that was case number 2. Case number 3. इसी तरह, let me just quickly add this as well. If you had, let's say, x minus x plus 2 cube, then you would write x plus 2 once, then x plus 2 with power 2, and then x plus 2 with power 3. And you'll have a, b, c, d, but they don't ask questions like this because it gets very lengthy. But you should know. Okay, next would be case 3. There would be a quadratic factor in the denominator. Quadratic factor in denominator. Take a look at the question. 4x plus 6 upon x minus 1, which is not a quadratic factor, but x square plus 9 is a quadratic factor. And this is the non-repeated case. So this would be the first denominator is going to be x minus 1. The other denominator is going to be x square plus 9. There's going to be a here. Acha, another thing you need to make sure is that just check if this can be further factorized into linear factor. For example, if instead this were x square minus 9, then we know we can write it as x square minus 3 square, which is a plus b and a minus b. So if it can be broken down into the linear factors, then you do that first and then you break it into partial fractions. But in this case, it cannot be further factorized. So now, in the numerator of the quadratic factor, you write bx plus c. Okay. And just in case if there was another one here, for example, x square minus 5, then you would add another fraction, x square minus 5, and here you write c ke baad dx plus e. All right. Okay. But that is not the question right now. Okay, now we will take LCM on both sides. So we'll get x minus 1 times x squared plus 9, a times x squared plus 9 plus bx plus c times x minus 1. And we have 4x plus 6 upon x minus 1 times x squared plus 9. Denominator cancels on both sides. Now I'm going to directly start the substitution process. We cannot make this 0 by substitution because x squared cannot be a negative value. So we can't get negative 9 instead of x in place of x squared. So we're going to try not to eliminate a for now. Instead, we're going to try and eliminate b and c. In fact, we can directly eliminate b and c by substituting 1 in x. So then both b and c term will get multiplied with 0 and we'll be able to find the value of a. So let x equals 1. So what do we get on the left hand side? We get 10 because 4 times 1 plus 6 is 10. And then we get, so the meeting will end soon and Heather will send me a meeting. So a times 1 square plus 9, which is 10. So a equals 1. Next, I am going to take x as 0 because what will that do? It will eliminate b and I will be able to find the value of c because I already have a. So let x equal 0. So we get 6 on the left hand side and when we have 9a, which is 9 times 1 plus b becomes 0. So we have c times 0 minus 1, which is minus 1. So we have minus 3 equals minus c. So I'm getting c equals 3. That is correct as well. Now all that's left to find is the value of b. So that I need a simple value of x. 0 ho gaya, 1 ho gaya. I'm going to take minus 1. Or you can also take 2 or minus 2, etc. So I'm going to take minus 1. So that is minus 4 plus 6, which is 2 at the left hand side. Then we have minus 1 whole square, which is 1, plus 9, which is 10, times a, which is already 1. So we get 10. Plus, we have minus b. plus c, which is plus 3, times x minus 1, which is minus 1 minus 1, which is minus 2. So we have minus 8 equals minus 2 times minus b plus 3. I'm going to divide both sides with negative 2. So I get 4 equals minus b plus 3. So I'm getting b equals minus 1, which is correct. Okay. So now we'll substitute the values of a, b, and c here. So a is 1. So we're getting 1 over x minus 1 plus b is minus 1. So minus x plus 3 upon x squared plus 9. This is the partial fraction. So that's case 3. Now let's do case 4. By the way, let's also quickly discuss this. What if we had x minus 1 and then x squared plus 9, and then a square on it? So now there are two cases being merged. There's a quadratic factor in the denominator and it's a repeated quadratic factor. So then it would be x minus 1 in the denominator of the first fraction, and then x squared plus 9 in the denominator of the second fraction, and then repeated x squared plus 9 in the third fraction. We'll just have a here, we'll have dx plus c here, and we'll have dx plus e here, if such a question comes up. Right. Now let's move to case 4. Case 4 is when we have improper fraction. Improper fraction requires long division. Okay. What is an improper fraction? Which of these is improper? 3 upon 5 and 5 over 3. Which is improper fraction? This is called a proper fraction. When the numerator is smaller than the denominator. This is called an improper fraction because the denominator is smaller or the numerator is bigger than the denominator. Then you can write it as a mixed number, 1 whole 2 over 3, right? Now it's a mixed fraction. So whenever you're asked to write an answer in the simplified form, it's advisable that if it is an improper fraction, you must write it as a fixed fraction. Also, you must know here that this 1 2 by 3 means that add 2 by 3 to 1. It's 1 whole part and then 2/3 part. So it's actually 1 plus 2, which we write together as 1 whole 2 over 3. So if it is 5.5, 5 whole 1 by 2, that means it's 5 plus half, 5.5. All right. All right. So now we're going to take a look at improper fraction case. So in terms of algebraic fractions, improper fraction is when degree of numerator, by degree we mean power of x. When degree of numerator is greater than or equals to degree of denominator. That is what is an improper fraction. The degree of the numerator if that is bigger than or equals to the degree of numerator. If that is the case, then you must do long division first. Write that as a mixed fraction and then proceed. Okay, let's take a look at the example. So we have x cubed plus 2x plus 1 upon x plus 1 and x minus 1. Okay. So we have linear non-repeated factors in the denominators. That's the case for A, B, and C. However, this is an improper fraction because the degree of numerator is 3. By degree, I mean highest power of x. And also the degree of denominator is 3. If you expand the denominator, you're going to get x cubed. So the numerator is an x cubed term, denominator is an x cubed term. So this qualifies as an improper fraction, which has to be fixed by long division. So we're going to do long division of this. Inside we have x cubed plus 2x plus 1. And outside this, we have, let's simplify this. We have x times, combine this, we get x squared minus 1. I've used the identity a plus b, a minus b. You can separately multiply the brackets as well. So x squared minus 1, which gives x cubed minus x. So divide this with x cubed minus x. All right, so that would be, we'll write 1 here. So we get x cubed minus x. And then change the signs. We have minus here, plus here. This gets cancelled. And we get 3x plus 1. Now the degree of the remainder is now smaller than x cubed. So we're done here. We can't further divide this. And Heather, please send a new meeting link before we proceed. So we can't further divide this. So I'm going to write this as a mixed number now. So we have 1 here, 3x plus 1 here, and x cubed minus x. So like I discussed before, this is actually 1 plus 3x plus 1 upon x cubed minus x. So now we have a proper fraction. It's to be cubed minus x. Okay. Now what we'll do partial fraction of this, and we're going to write the denominator in the original linear format, the factorized format, x times x plus 1 times x plus. So we're going to go back to that format for the denominator. So 1 stays the same, plus denominator is x plus 1, x minus 1, numerator for that is 3x plus 1. Okay, so we can ignore the plus 1 at the left for now and do partial fractions of 3x plus 1 upon that. And in the end, we'll add 1 to our answer. So let's start breaking this down into partial fraction, just this. So that would be, just this would be a upon x plus b upon, just wait when after a while the screen starts to glitch, x plus 1 plus c upon x minus 1. Okay. Equals to sign in between. Take LCM at the right hand side and then you cancel the denominator. So that would be x plus 1, x minus 1. In the numerator, a gets multiplied with x plus 1, x minus 1, plus b times x minus 1, plus c times x plus 1. Okay. And the right hand side is the same, 3x plus 1 upon x times x plus 1 upon x minus. Okay. So cancel this, cancel this. So we have 3x plus 1 equals all of that. I'm going to start with let x equals minus. Okay. So for that, we get minus 2 on the left hand side. Equals, a gets eliminated, b does not get eliminated, c gets eliminated. So we have b times minus 1 times minus 2. So we have 2b at the right hand side, minus 2 divided by 2 would be minus. So b equals minus.
मैम इस केस में x plus 1 और x minus 1 को combine करके नहीं solve कर सकते वैसे x square minus 1 जो quadratic case 3 था
नहीं ना, क्वाड्रेटिक केस में जरूरी होता है कि अगर वो क्वाड्रेटिक फैक्टर फर्दर फैक्टराइज हो रहा है तो आपने पहले करना हो। ठीक है, तो अगर ये डिनोमिनेटर में आप लिखते भी एक्स स्क्वायर माइनस 1 तो आप इसको क्वाड्रेटिक केस में नहीं कर सकते क्योंकि ये फर्दर ब्रेक डाउन हो रहा होता है एक्स प्लस 1 और एक्स माइनस 1 में। ठीक है, क्वाड्रेटिक केस तब भी लेना होता है जब वो फर्दर ब्रेक डाउन नहीं हो सकता, वरना उसको लीनियर केस ही लेना हो। ठीक है
मैम।
Okay, so b is minus 1. Now I am going to take x equals 1 ले लेते हैं, इससे b कैंसिल हो जाएगा और a भी कैंसिल हो जाएगा, c की वैल्यू आ जाएगी. So x equals 1, let x equals 1. So we get 4 equals, a gets cancelled, b gets cancelled. So we get c times 1 times 2. So we're getting c equals to 2. And next, I'm going to take x is equals to 0 because that's going to eliminate b and c from the equation. So let x equals to 0. So we have 3 times 0 plus 1, which is 1, equals a times 1 times minus 1. 1 times minus 1, and the other two expressions become 0. So we have a equals minus 1. So we get minus 1 over x. There's a plus 1 with the answer as well. So 1 plus minus 1 over x plus b, so b was -1 again, so in fact ये -1 इधर लिख लेना चाहिए नीचे fraction के बाद, minus here, and b is -1 again, so -1 upon x plus 1, and plus c is 2, so 2 over x minus 1. This is the final answer in partial fraction. Let me check the answer. Yes, it is correct. Okay. Let me just quickly open a new board. This one is glitching like crazy. Okay. Anything else left to discuss? No, I think that's all. All right. I think I should just give you a few example questions as homework from all these cases. Acha, ye to case tha where the degrees were the same. Numerator was x cube and denominator was x cube. Again, you will see cases where, for example, numerator is x4 and the denominator is x cube. So this is also a case of improper fraction. You will do the long division. You'll write the answer in the mixed form, and then you split it. For example, you get 3 whole 2x plus 1 over x4 plus whatever. So then you split the 3 and then you will do partial fraction this. All right, so I think that's all for today. और अब homework में मैं बाकी questions दे दूँ. All right, चलो. Take care. See you tomorrow. Allah Hafiz.
Yeah.
Allah Hafiz.
Tomorrow inshallah we'll start binomial expansion. और homework करना है याद से.